Good morning, everybody. So last class we got through this section here, 11, fundamental theorem of calculus and accumulation. We got to the end of this example here. The one where we were adding and subtracting bananas from a display table at a grocery store. Are there any questions on that before we go on to the next one? Or anything else for that matter that we covered last class? Okay, so this example here is another full response question that you'll be similar to what you'll see on your AP exam. It comes from a practice exam in 2016. And this is a real good example because it ties together multiple concepts from the course, not just on integration, but you'll see how we can bring into this type of question, how do I find, so revisiting, how do I find the maximum and minimum value, or the absolute max and absolute minimum value of a function? So we've got a beehive, contains 3,500 bees at time t equals 0. During the time interval from 0 to 4 hours, bees enter the hive at a rate modeled by E as a function of t is 16t minus 3t squared. So they're entering the rate given by E of t, and that is measured in hundreds of bees per hour. Okay, again, units, hundreds of bees per hour. During that same time interval, from 0 to 4, bees are leaving the hive at a different rate modeled by capital L of t, which is negative 2t plus 15. And again, that rate is also measured in hundreds of bees per hour. So this is a little simpler. The context is a little simpler than the last question, even though it's pretty much the same idea. Something is being added and removed, and this time we're talking about bees. Part A, how many bees, and I've highlighted, leave the hive during the time interval from 0 to 2. So it's not asking how many bees are in the hive. It's not asking what's the total number of bees. It's not asking how many bees enter the hive. It's just how many bees leave the hive. So if we integrate the rate at which bees are leaving the hive over that time interval from 0 to 2, then that'll tell us how many bees have left the hive. So we've got to integrate from 0 to 2, capital L of t, which is negative 2t plus 15. And this should actually be in brackets with a dt on the end. Okay, so what does that mean? It means we need to find the antiderivative of negative 2t plus 15, sub in 2 and sub in 0. So the antiderivative would be negative t squared plus 15t. I'm going to sub in 2 and I'm going to sub in 0. That's what that vertical line means. So that would be negative 2 squared plus 15 times 2. Subtract negative 0 squared plus 15 times 0. So that second bracket, that second large bracket is 0. So I've got negative 4 plus 30, subtract the 0, gives me 26. And so you need to pay attention to the units. It's not just 26 bees, it's 2,600 bees leave the hive, because the units for L of t was measured in hundreds of bees per hour. So our answer is 2,600 bees leave the hive. Any questions on that? Pretty straightforward, I think. Okay, part B. Write an expression involving one or more integrals for the total number of bees in hundreds in the hive at time t, where t is some value in between 0 and 4. So that's the first part of the question. And then find the total number of bees in the hive at t equals 4. So if we want to know the total number of bees in the hive at some value of t, now keep in mind, t is not 1 or 2 or 3, it's any value in between 0 and 4. So we're going to write an expression that will allow us to sub in any value of t later on to find the total number of bees in the hive. So if I want the total number of bees in the hive at some time t, then I'm going to start off with the 3,500 bees that were initially in the hive. Then I'm going to add to it the total number of bees that enter the hive and subtract the total number of bees that leave the hive. So that first integral there, the integral from 0 to t of e of x dx, that will give me the total number of bees that enter the hive in the time interval from 0 to t. And that the only valid numbers for t are anything between 0 and 4 here, okay? Now I want to highlight again, and it may be confusing to you at first. E here is written as e as a function of x, and my limit up here is a different variable, time. Okay, we've been asked to use a variable of time here. So originally the question gave us e of t and L of t. So those are functions of time. We have to change those to some other variable so that it's different than our variable time. Now, when you have a function, whether the variable is x or u or w or t, it doesn't matter. When you integrate, that doesn't change anything. Just calling the variable something else won't change the result, okay? So it's not a big deal to change that t to an x here. Now, the second integral, what I'm going to subtract, is the number of bees that are removed from the hive in that time interval from 0 to t. And to get that, I would integrate from 0 to t L of x, which is the rate at which bees are leaving the hive. So if you wanted to, you could combine those two integrals into one and write 35 plus the integral from 0 to t of e of x minus L of x dx. That will give you the number of bees at any time you want in the hive, between 0 and 4. So on the right there, all we need to do to figure out the second part of the question, which is find the total number of bees in the hive at t equals 4. So all I'm going to do is sub t equal 4 into my integral equation there. So 4 is going to become the upper limit of integration. So it's 35 plus the integral from 0 to 4 of, and I really should have wrote that as x, not t. Let me change that. So these should have been written as x's. What was this? 16x minus 3x squared, and then this should be an x. Now, this problem was designed for you to do without a calculator. So this is the type of problem you would get on the AP exam where you would not have a calculator. Okay, so in order to do this, you would have to integrate or find the antiderivative of these two functions here. For the sake of time, I cheated and used the calculator, but I'm hopeful that you would be able to find the integral or the antiderivative of that function. And actually, you can see over on the right-hand side, it's actually done for you. It's actually written out. Over here, it's typed out. Okay, so all you do is you expand the 16x minus 3x squared. That becomes plus 2x plus 15. You collect like terms, and then you just find the antiderivative of negative 3x squared plus 18x minus 15. That would be negative x cubed plus 9x squared minus 15x. Okay, sub in the 4, sub in the 0, subtract the 2, and you end up with 5,500 B's. If you use the calculator, you would get the exact same thing. So I just use the calculator to save space and time. So your answer, the number of bees, the total number of bees in the hive at T equals 4 is 5,500 bees. Any questions on part B? Okay, so part C is asking you, so now this is where previous concepts that we've studied come into play into this question. Find the minimum number of bees in the hive for the time interval 0 to 4, and then justify your answer. So we need the minimum number of bees. So for any function, and we've got a function in part B, the first part of part B, we wrote a function that describes the total number of bees in the hive at time t equals 0. So that function there, that 35 plus the integral from 0 to t of e of x minus L of x dx, that is a function representing the total number of bees in the hive at any time between 0 and 4. We need to find the minimum value of that function, the absolute minimum value of that function. So when you hear that absolute min or absolute max, you should be having flashbacks to before Christmas. We spent time talking about that and how we do that. And so I've just written there in red for you to find the maximum minimum value of a function. Okay, to find the absolute max or absolute minimum value of a function, we need to look at the endpoints or at the critical values of that function. Those are the only places that you can have an absolute minimum or absolute maximum value of a function. At the endpoints of the function, which in this case would either be at t equals 0 or at t equals 4. But you might also have your absolute minimum or maximum value at a critical value. Now, what's a critical value? Well, critical values occur where the derivative is either equal to 0 or the derivative doesn't exist. So we've got our function there. I've called it b as a function of t that represents the total number of bees. We need to find the critical values of that function. And then what we're going to do is we're going to evaluate that function at the endpoints and at the critical values. Now, the difficult or the new part to all this is how do so basically, in order to find critical values, I need to find b prime. I need to take the derivative of that thing. But I've got an integral in there. And so how do I deal with taking the derivative of an integral. Everybody okay so far? So again, we're trying to find an absolute in this case, it's an absolute min. Absolute mins can only occur at endpoints of a function or at critical values of a function. So we're going to have to find the critical values of our function b of t. But the problem is I'm not quite sure how to deal with finding the derivative of that integral there. So I've created another note here just to cover that. Okay, now we're going to talk in more detail about this later on, and I'll explain when we get to the end of the note why we're going to do that. So the fundamental theorem of calculus is this: the integral from a to b. So we're just going to step back from that problem here, and I'm going to go through how do we find the derivative of a function that has integrals in it. So we can start with the fundamental theorem of calculus. The integral from a to b of some rate of change function f prime is just equal to f at b minus f at a. That is a value. F at b minus f at a would be a value. Now, hopefully that's not new to you. We've covered this already. If you allow the upper limit to vary, in other words, if our upper limit now becomes t, some other function, and the lower limit stays as a number, then the fundamental theorem of calculus becomes the integral from a to t of f prime dx is just equal to f at t. So little f is the antiderivative of f prime evaluated at t minus the antiderivative of f prime evaluated at a. But the difference now is that the result is a function of time. Okay, because we've got an upper limit that's a variable, so the result will be a function of time. Now, what does it represent? So I've kind of drawn a little graph there. And if you can just pretend that that red curve is f prime, then that definite integral from a to t just represents the area under the curve starting at a all the way up to t. But just keep in mind that t can move left and right. T is variable, so it can move anywhere along that curve. It can move left or right. It can even be on the left-hand side of a if we wanted it to, if the function went past there. So t is moving. T can be any value. Okay? So there under the graph, again, I've summarized the integral from a to t of f prime is f at t minus f at a. That result is a function of time. Now, what happens if we take the derivative of that? So what happens if I take the derivative of the integral from a to t of f prime of x dx? Well, if I just use that expression there in red, just under the graph, if I take the derivative of the left-hand side, that will be equal to the derivative of the right-hand side. Okay, so the derivative of that integral will be equal to the derivative of f at t. Keep in mind, little f is the antiderivative of f prime, minus f at a. Well, what is the derivative of f at t? The derivative of f at t is just f prime. And what is the derivative of little f evaluated at a? That would just be 0, because f at a is just some number. It's a constant. It's a value. It's a function evaluated at some number. So when you take any function evaluated at a number, you're going to get a value. And when you take the derivative of that, it will be 0. So the result, the derivative of that integral from a to t of f prime dx is just equal to f prime of t. So, two more simple examples to illustrate what's happened here. Let's say let's say I have the integral from 0 to t of 2x dx, and I want to know what the derivative of that is. What is the derivative of the integral from 0 to t of 2x dx? Well, first of all, I would have to evaluate the integral, find the antiderivative, evaluated at t, and evaluated at 0. The antiderivative of 2x is x squared. When I sub in t, I get t squared. When I sub in 0, I get 0 squared. T squared minus 0 squared is t squared. Now take the derivative of t squared, and I get 2t. Notice the answer is the exact same expression as the integrand, but evaluated at the upper limit t. So it's the integrand 2x with the x replaced by our variable upper limit, which is t. Second example, I want the derivative of the integral from 3 to t of e to the x plus cos x dx. So it's a little more involved, but it's the same thing. To find the derivative of that integral, first I need to evaluate the integral. So the integral of e to the x, the antiderivative is e to the x. The antiderivative of cos x is sine x. And I have to evaluate that at t and evaluate it at 3. So I would get e to the t plus sine t. Subtract, now sub the 3 in there, e to the 3 plus sine 3. So I get that expression, e to the t plus sine t minus e cubed minus the sine of 3. Now I need to take the derivative of that. The derivative of e to the t is e to the t. The derivative of sine t is cos t. The derivative of e cubed is 0, and the derivative of sine of 3 is 0. Okay, because e cubed is just a number, and the sine of 3 is just a number, a value. When I take the derivative of a constant or a value, it's 0. So what happens again, I get that the answer is the exact same as the integrand I started with, evaluated at that upper limit t. So in general then, if you want d by dt, the derivative of that integral from a to t of some function, then you don't actually have to go through all that work every time, because it's always going to just be the integrand evaluated at that upper limit t. Okay, that expression there is known as part 2 of the fundamental theorem of calculus. We're going to talk more about it later. Okay. The reason we need to talk more about that thing later is because it is possible to have an integral with both the lower and the upper limits being a variable. In other words, you wouldn't have the integral from a to t, you might have the integral from t cubed to cos t. And then how do I deal with that if I want to find the derivative? Okay, but that's coming later on. For now, that expression there gives us a way of determining the derivative of an integral when we have a lower limit that's a number and the upper limit that is just a value, a variable like t. Okay, all we do is take the integrand, the f of x, and sub in the t. Any questions on that? So that's going to help us solve that problem. Any questions before I leave this page? Conceptually, it's not difficult. I understand sometimes the notation can be difficult to follow. You just need to kind of take your time and process it. But the result is pretty straightforward. So back to the question. We had the total number of b's and we're looking for critical values, which means I need to find the derivative of that function 35 plus the integral from 0 to t of e to the x minus L of x dx. Okay, so take the derivative of 35, that's 0. And then I'm going to take the derivative of that integral expression. Well, the derivative of that integral expression, based on what I just tried to explain to you, is just going to be e to the x minus L of x, evaluated at that upper limit variable, which is t. So b prime turns out just to be e of t minus L of t. That's it. That's our derivative for the number of b's. Now, to find the critical values, I need to set that equal to 0 and also find out where it does not exist. So on the left-hand side there, I've subbed in what E of t is and what L of t is. Okay, so we need to figure out when is 16t minus 3t squared plus 2t minus 15 equal to 0. Okay, you can see the math there. Just collect like terms. I can factor out a 3, and then I can factor that quadratic, and I get 3 times t minus 5 multiplied by t minus 1 equals 0, which means that t either equals 5 or t equals 1. Now, pay attention to the values you get. T equals 5, I can't use that in the problem. That has no merit here because I'm only interested in what's happening between 0 and 4. That's what the question asked. Find the minimum number of bees in the hive between 0 and 4. So I don't even have to worry about the t equals 5, but t equals 1 is a critical number. In fact, it's the only critical number. Okay? Because there are no values where b prime of t does not exist. Okay, b prime of t is just that expression, 3t squared minus 8t plus 15. That's a polynomial. Polynomials are defined everywhere. It's not a rational function. There's no denominator that I can't let be 0. So there are no values where the derivative doesn't exist. So the only critical value is that t equals 1. So now how do I use that? I got to take my original function that represents the total number of bees, and I'm going to evaluate it at the endpoints 0 and 4, and I'm going to evaluate it at the only critical value we have, which is t equals 1. Okay? So at the left endpoint, where t is equal to 0, I sub 0 into my function for b of t, not b prime, b of t, the total number of bees. Okay, so that's 35 plus the integral, maybe I should write that out, plus the integral from 0 to 0 of e to the x minus L of x dx. That answer is 35. It's also given to you in the question. There are 3,500 bees at time t equals 0. So we know that right away without even doing anything. Then for the critical value, I'm going to sub 1 into that function b up here. So that's 35 plus the integral from 0 to 1 of e to the x minus L of x dx. And so I cheated again to save time. I did this on the calculator and I got 28. So it's 2,800 bees at time t equals 1. And then the other possibility where I might have the absolute min is at the right end point. So I sub 4 into that integral. And I would have 35 plus the integral from 0 to 4 of e of t minus L of t. But we already did that. We did that in part B. It's this function right here. Okay, again, I cheated back then, but the answer was 5,500 bees. So at the right endpoint, at t equals 4, the number of bees in the hive is 5,500. So you could have been asked what's the absolute maximum number of bees in the hive, but we're asked the absolute minimum number of bees in the hive. So I compare those 3 green highlighted numbers at each of the endpoints and the critical value. So it's obvious the minimum number is 2,800 bees, and that occurs at t equals 1. And if they asked you the absolute maximum number of bees, you would do all the same thing, and your result would be that the maximum number of bees in the hive is 5,500, and that occurs at t equals 4. Any questions? So This question demonstrates the type, the complexity. It's really good at demonstrating the complexity of the full response questions you will be seeing on the AP exam. And it's good because it ties together a lot of concepts. It ties together, how do I find the absolute min and max of a function? It ties together the fundamental theorem of calculus and both parts of it, part one and this new part, which I covered here, which tells us how to find the derivative of an integral function when the upper limit is a variable. So there's a lot going on in that problem. And that's pretty much how the full response questions will be for the AP exam. Any questions on any of this, anything we covered today, or any part of this note number 11 here that we went through? We started last time we were together. Any questions? Okay. The next concept we need to cover is position, velocity, acceleration, and how those three things relate to the fundamental theorem of calculus, and just in general, how those three quantities are related to each other in terms of calculus. I'm hesitant to actually start this today. So I don't think I'm going to, but I need to say this. Your assignment now that you're working on, you should be able to do every single problem on here with the exception of this question here on page 9. Okay, and if you read it, you can see that this question involves position, velocity, acceleration, and so you won't be able to, you can try it, you can read the note and try it, there's nothing wrong with that. But if you're short on time, all I'm saying is that you should be able to complete this entire assignment with the exception of number 7. So please, I'm not going to collect the assignment the first time that I see you next week. But once we cover the entire note on position, velocity, and acceleration, I am going to ask you to hand this assignment in the day after, because you only have the one question to finish. Okay? So you can complete the assignment with the exception of number 7. We'll figure out when you're going to hand this in next week, but it'll be the day after we complete the note on position, velocity, and acceleration. Now, if you want to get a head start and start reading this, it's not rocket science. It's not too difficult. I've tried to detail as much of an explanation as I can in here. We will go through it all together, but it's not until we're finished this note that you'll be able to finish that problem from the assignment. So, which brings me to the next thing, the assignment. Are there any questions that you want to ask since we have some time here? Are there any questions that you're having trouble with on the assignment that you need clarification on, or to me to show you how to do it, or to point you in the right direction? Now is the time to ask. And if you don't, that's okay too.
Sir?
Yeah.
Can we look at 2D, please?
2D. All right. Let me make this smaller so I can see what I'm doing here. So you're being asked, find all possible values of B such that, I'm sorry it's small. Find all values of b such that the integral from 10 to b of f prime of x dx is equal to 0. So right away, without even lifting a pencil, can you give me one value of b that will make that integral 0?
Would 0 be 1?
It might be, but I know for sure, I know there's one value for sure that'll make that integral 0, and that's 10. Right? Whenever the lower limit and upper limit are the same value, the integral is automatically going to be 0. So if you had no clue and you wrote b equals 10, you would get a mark for that, because that's the obvious answer. But that's not the entire answer, unfortunately. So the idea here is you have to find a value of, so here is the graph of f prime. So I need to go up here for a bit and look at this graph. This graph represents b prime. Okay, so if we're starting at 10, okay, this integral here in the question, let me write it up there. The integral, we need to figure this out. The integral from 10 to some value of b of f prime dx, that has to be equal to 0. So I'm going to start shading. I'm starting at 10, so I'm actually integrating this way, right? So this area here, that is going to, because I'm integrating from right to left, that will contribute a positive value to the definite integral. And what I need to do is I need to find some number between 6 and 0 that I can integrate to that will cancel out this yellow shaded region. Does that make sense?
Yes.
So what I'm saying is, if I just integrate to there, if I integrate from 10 to 3, will that give me 0? So we can do a quick calculation. What's the area of this triangle? 9 divided by 2, so that's what, 4.5 is the area of that triangle? You agree with that?
Yeah.
Okay, if I make a mistake, let me know, please. And then that's a half circle there with a radius of 2. So the area of that would be 1/2 pi times 2 squared, which is 2 pi, which is, I don't know, what's 2 times pi? 6.283. Right. So if I started integrating from 10 and I only integrated to 3, am I going to get 0? In other words, is 4.5 enough to cancel out this 6.283?
No.
No, so I need to keep going, right? But how far? That's the question. So what you can do is draw a random line somewhere. Okay. Call this distance x. Okay, we're forming a rectangle here. The height of that rectangle is 3. Okay. So what has to happen is the area of that rectangle, which is 3x, plus the 4.5, right? That has to equal 2 pi. Do you follow that? The area of that red rectangle plus the blue triangle has to equal the area of that half circle. That's the only way our integral will be 0. So that'll allow you to find out what x is. Okay, but just be careful when you're figuring out what b is. So you're going to use that x value to figure out what b is. Is that enough to help you figure it out?
Yeah, thank you.
No problem. Any other questions from the assignment you need assistance with or want to ask about? Nothing? That means you guys haven't done it or it's easy.
Sir, I have a question.
All right.
Can we look at 1D?
1D. This one here?
Yeah.
Okay. Let me make it a little bigger. Okay, so the integral from 0 to 5 of e to the x plus 2 times g of x dx. So this is meant somewhat to, I don't know if it's meant to confuse you, but first thing to do is to write this as two different integrals. The integral from 0 to 5. Somebody has their mic on. I'm not sure who. Can you turn it off? So first of all, figure out that integral, and then you're going to add to it the integral from 0 to 5 of 2 g of x dx. Now, this I can write as, the first one I'll leave alone. I can bring this 2 out front, so it becomes 2 times the integral from 0 to 5 of g of x dx. Now, this first integral has absolutely nothing to do with the graph above. 0. You have to find the antiderivative of e to the x and sub in 5 and sub in 0 and subtract the 2. This integral, the second one, can be interpreted as the area under the graph from 0 to 5. So let me highlight that up here. It's this. So I'm going to find that area, and I'm going to multiply it by 2. But this one here that I've highlighted in blue, the antiderivative of e to the x is just e to the x. And I'm going to evaluate that at 5 and 0. So I'm going to get e to the 5 minus e to the 0, which is e to the 5 minus 1. So that's just this part, plus 2. And then you're going to figure out what that highlighted region is up there on the picture, and then you're just going to add the two numbers together.
Okay, thank you. That makes sense.
Okay. Yeah, so that e to the x has nothing to do with the graph. Same with b. This is the integral from 1 to 4 of x dx plus the integral from 1 to 4 of g of x dx. This you're going to get from the graph. Okay. This one has nothing to do with the graph. The first one. You have to find the antiderivative. Okay. Which is x squared over 2. And then I'm going to evaluate that at 4 and 1. So that would be 4 squared is 16, which is 8 minus 1/2. And part C is very similar as well. Okay, so you got to break those up. Part of it will come from the graph above, and part of it may have nothing to do with the graph.
Sir, I had a question for the absolute value stuff.
Okay, which one? A or C or any of them?
Kind of C. So I did A, and I kind of just put the whole graph above the x-axis, and then did it like that.
And that's what you should do. So you should have, let me see here. It would look, I mean, you don't really have to draw it, but it would be that, right? And then I'll just trace over the rest of it in blue.
Right. But then for the bottom question, where it's like you go from negative for C, when you go from -2 to 5, since it's like
From
in,
-2 to -5.
sorry, at -2 to -5, since it's going left, would it then, that area be negative, even though it's the absolute value, or it's still positive?
So it's, what is it? -2?
Yeah.
So it's this, right?
Mm-hmm.
So you're integrating from right to left, and that is above the x-axis. So it would be a negative value.
Okay.
Does that make sense?
Yeah.
Any other ones? Actually, I didn't do a good job of drawing that. That drawing is actually not correct. It should be more like that. That's a little better. So it's just a rectangle. Any other questions? Come on. Nobody? Nothing? Okay, guys, if you got no other questions, you're free to go. I guess I don't see you again until next week, right? Am I correct?
Yeah.
So, do you know if next week is all like day 2s and day 4s? Or is it like day 1, day 2, and 3, 4?
Hold on. Because we had a meeting yesterday. I haven't got anything, I haven't got an email, but Mr. Costanzo said something about it being a week 2. Now, I don't know what a week 2 means. Do you guys know what a week 2 means?
I think that means that we have you all week, sir.
Yeah, on Edsby, it says it's like day 2, day 4, day 2, day 4.
Okay. All right. So, so then I don't see you till Tuesday, right?
Yeah.
Okay. So the assignment I'll collect sometime next week, but it won't be till later on in the week. It's just so that we can cover the velocity and acceleration and position business.
Sir, if we're not at school, do we just post it in OneNote?
Yes, please. Any other questions, guys?
I'm sorry, I have one more question.
Okay, good. Well, that's what we're here for. What do you got?
For 8B.
8. Holy smokes, that's way down here.
So the question is to evaluate 1 to 6 integral. So I know how to do like the 1 to 3, and then since 3 to 6 is like the parabola function.
Right, good.
I did like, I separated the two integrals, and then
Excellent. And so you have to evaluate this, the integral from 3 to 6 of 2 minus x, x minus 4 squared dx.
okay, because, or would I do like integral of 1 to 3 of that function? Because isn't that like a new function? It like, and then it would be like 1 to 3.
So, okay, part B asks you for the integral from 1 to 6. So the integral, you can write that like this. This is equal to the integral from 1 to 3 of g of x dx plus the integral from 3 to 6 of g of x dx. This integral right here is just this area here that I'm going to highlight.
Mm-hmm.
Okay. The rest of it is so you actually have to do now this, the second one, this thing right here is this.
Right, but like, because it's a new, like they gave us like this new function, wouldn't you have to do like 0 to 3 or something for like this new parabola?
No, because the parabola is only valid from 3 to 6. You see how it says, and g to g, so this the entire graph is g of x, but what they're saying is that part of g of x from 3 to 6 is just this parabola here.
Okay.
Okay. Does that make sense?
Yeah.
Right. So when you actually go and find that integral, it's going to represent this blue shaded region and this, which we can't find using geometry because those lines are curved. So you have to actually find the antiderivative.
Okay. Okay, thank you.
You're welcome. Anything else? Okay, guys, if there's nothing else, I'll see you next week. Have a wonderful long weekend. Happy Valentine's Day. And I hope I see you on Tuesday.
Thanks, sir. Have a good weekend.
Thanks, you too.
Bye, sir.
Thanks,
Have a
sir.
good
Bye.
weekend.
Thanks, sir. Enjoy the long weekend.